Good morning, Simon Tech Huskies. Welcome to week 3 of distance learning. I am Mrs. Ruvalcaba, and this is my recorded lesson for Mondays and Tuesdays. Let's take a look at the agenda. 3 things: the reminders, the assignment overview, and also the lesson. Now, the reminders are that you do your attendance every single day on Google Form. My flex hour is later today from 2:15 to 3 o'clock p.m. So they will be on Mondays reserved for periods 1, 3, and 5, and Tuesdays for periods 4 and 6. Please come to my live sessions on Wednesdays and Thursdays. So on my live sessions, there will be the weekly surveys where you guys will take a short and easy survey, not an essay. So short and easy means it's an easy grade for that part. Wednesdays for my live sessions will be reserved for periods 1, 3, and 5, and my Thursday live sessions will be reserved for periods 4 and 6 during those normal class times. And the last reminder, please complete and turn in your assignments by Sunday, 11:59 p.m. Now, the assignment overview, your assignment should look like this. It's posted on Google Classroom. And the first part will be analyzing this table here. This is your literacy part. You will be reading this carefully and then answering the 2 questions based on the table. And the next parts of this assignment will be videos, and I have created questions for you that I believe are the most important parts of the video that I hope you will be remembering and taking away from the lesson. The first one is about the composition of Earth's atmosphere. The second video, atmosphere and solar radiation. The third one, conduction, convection, and radiation. And the last one, causes and effects of climate change. Now, this lesson is about 5.1, chapter 5.1, the composition and behavior of the atmosphere. Unit 5 is our last unit of this year, and this is the first chapter of the last unit. Your objective, students will be able to determine the elements that make up the atmosphere, how heat transfers in the atmosphere, and how human activity alters the atmosphere. The standard for this lesson, HSESS 2-4, use a model to describe how variations in the flow of energy into and out of Earth's systems result in changes in climate. The first critical academic vocabulary I want you to be familiar with is the word composition. Composition is the combining of distinct parts or elements to form a whole. What is something made out of? The sample sentence is: the composition of each soft gel pill of Vicks NyQuil cold and flu are 325 milligrams of Tylenol, 15 milligrams of Robitussin, and 6.25 milligrams of Vicks. Those are the 3 active ingredients that help you with your illness. Now let's talk about the composition of the Earth's atmosphere. What is the Earth's atmosphere made out of? Your first assignment will have you analyzing this graph where you will be comparing and contrasting the 3 different types of atmosphere, how they were formed, what each one was made out of, and what happened to each one that eventually resulted in the Earth's current atmosphere. So for you guys to have an idea of what happened before and comparing that to now, let's take a look at this model of Earth's prebiotic atmosphere and compare that to the modern atmosphere, what we have right now. So for prebiotic atmosphere, do not confuse that term prebiotic for the nutrition terms, probiotics, prebiotics, the stuff that they sell. That they're trying to sell you on the commercials. Here, prebiotic means before life, before the start of life on Earth. So the prebiotic atmosphere doesn't necessarily have a lot of plants or organisms that help photosynthesize and creates the oxygen that we all use. But later on, when organisms start to evolve, especially plants were able to take in the carbon dioxide and spew out as their waste product oxygen. And this is the oxygen that we use. So compare and contrast. From before, there was a lot of carbon dioxide back then. Compare it to now, there's a lot more oxygen compared to carbon dioxide. And the Earth's atmosphere is still made of a lot of nitrogen gas. The second largest component is oxygen, and the rest are smaller parts. Carbon dioxide is 0.038% according to this chart here, and there are trace amounts of other gases as well. That would be other gases would be neon, helium, methane, water vapor, krypton, hydrogen, xenon, and ozone. And this part over here is argon, less than 1%. Now, the critical academic vocabulary that you need to know for this next part is radiation. Radiation is the release and flow of energy in the form of waves, rays, or particles. And your sample sentence, the sun emits radiation in the form of light, heat, and particles. Now, you can see over here, the sun, you can see that the energy is radiating out before it hits the earth. They are in the form of waves, rays, or particles. Now, the solar radiation and the atmosphere, how they are involved. We don't receive all 100% of the solar radiation. Rather, we receive about 50% of that. The remaining 50% that hits the Earth, they will either get absorbed in the atmosphere through the clouds, and some of them will bounce off. They will be reflected off back into the atmosphere, and some of them are scattered all throughout the atmosphere as well. So 3 things happen to solar radiation when it reaches our atmosphere. They can be absorbed, they can be reflected back out, or they can be scattered. The other part of the atmosphere I really wanted to get into involves this molecule here. It's made up of 3 oxygen atoms covalently bonded, and it is what is known as ozone. So now you know that ozone is made up of 3 oxygen atoms covalently bonded. And just so you know, we all know that ozone is what protects us from harmful UV rays, but we only want that protective layer in the upper atmospheric layer, way high above us, above our troposphere. The troposphere is the ground level atmosphere. You don't want this ozone into the ground level where we're at, because ozone is actually a harmful pollutant. So this is what I'm talking about here. You want the ozone to stay up here where it can absorb those harmful UV rays. The most harmful UV rays are UVC and UVB because they've got short wavelengths. And if you remember from last semester, short wavelengths means that they vibrate a lot faster, meaning they've got a lot of high energy. UVA rays have longer wavelengths, so they don't have as much energy, but you still want to protect yourself from UVA rays by wearing sunscreen. Okay. I had to cut myself there. Moving on to the greenhouse gases. What greenhouse gases are, these are the gases that trap energy from the sun and helps warm up the earth. They have a greenhouse effect. Like, if you know what a greenhouse is, it's a house made out of glass that houses plants. It keeps all of the light's energy inside the house to keep the plants warm and thriving. So it's the same concept for us. The atmosphere will help trap in the air as well. And from the atmosphere, it's the greenhouse gases that do that. And what are the greenhouse gases? Well, I hope that we all know. The big one that we all know about is carbon dioxide. Other greenhouse gases that help trap the energy from the sun are methane, nitrous oxide, and the fluorocarbons here, hydrofluorocarbon and perfluorocarbon. And this one, I believe, is sulfur hexafluoride. And from what you can see over here, the large part of our carbon dioxide was a result of fossil fuel combustion, so human activity. And let's get into the three types of heat transfer that occurs on Earth. There is conduction, radiation, and convection. With conduction, heat is transferred from an area that's hotter to an area that's cooler. So heat has a tendency to transfer from where it's hot and spreads it all out to where it's cooler, trying to even things out. With conduction, heat will be transferred when particles are in direct contact with each other. Radiation, you don't need anything touching anything. Radiation are particles or wavelengths that can travel through empty space. And convection is the transference of heat through fluids. And if you guys remember, fluid doesn't necessarily mean liquid. Fluids can also be gases and liquids. That's why we can see convection occurring in the oceans and also the atmosphere. Okay, before I go there, and if you guys remember what convection is, that's when there is a source of heat that heats up one part of the particles in the fluid. Those particles will start moving fast and will rise up. They become less dense, and when they cool down, once they cool down, they become more dense and sink until they are heated up again. So remember that convection is a circular motion. As for the heat distribution of Earth, remember that our Earth spins on an axis and it is also tilted. And the position of our Earth means that the sunlight will strike directly towards the equator. The other parts that the sunlight hits, the northern hemisphere and the southern hemisphere here, you can see that there are larger angles of how the sun is hitting. That means it's not a direct hit. Where the sun hits directly will be near the equator, and that would explain why the center part over here in this graph, there is a higher amount of heat near the equator. So there is an uneven distribution of heat going on through Earth. And with the movements of convection, it helps transfer some of that heat to the areas where there are cooler. Until those particles cool back down, they sink back down, and they get heated up again where they'll move to the areas that are cooler again. Now let's talk about the CO2 levels of Earth. We can see that back then it wasn't that much of carbon dioxide emissions until the event of agriculture and the Industrial Revolution, which produces more carbon dioxide into the air. And you can see that it's a large exponential growth, a J curve. And you can see that it is still increasing. This was since 2017. And with the increase of carbon dioxide, if you follow this black line here, with the increase of carbon dioxide, there is also an increase of global temperature. And this model also compares from 1884 to 2015. As the years go by, the Earth is getting hotter. Now let's talk about the consequences of climate change. With climate change, with the Earth's temperature increasing, the glaciers have started melting. They are still melting. And with the glaciers melting, that water is traveling to other parts of the Earth, which causes higher sea levels, which is what's happening in Venice here in Italy. And also with climate change, that means there is a higher content of carbon dioxide that's mixed into the oceans. That makes the oceans more acidic, which is really bad for certain habitats like the coral reefs are bleaching, they are dying, and it's also a domino effect on the food web. Others are being affected as well. There will be drastic temperature changes, large amounts of rainfall and snowfall, as well as longer droughts, dry spells, which in turn will destroy certain crops. It won't be as easy to grow crops as before, so there will be a shortage of food. And don't forget, with the consequences of climate change, that means more pollutants in the air. So that's also bad for our health, which results in asthma and heart disease. But there is hope out there. I know we all don't like the stay-at-home order, but there is a silver lining. Take a look at the levels of pollution back in January to March in Italy right now. So everybody, please stay safe, and hopefully everything will get better, and I'll see you guys soon. Bye.